Today I'm going to talk to you about cancellation. Cancellation is something that we use when we're multiplying fractions, and it's a way to actually simplify our fractions before we even multiply them. So we talk a lot about reducing or simplifying our products or our answers when we're finished adding, subtracting, or multiplying fractions. But when you use cancellation, you can actually simplify a fraction or a set of fractions before you even multiply them. I'm going to show you what this looks like and why we do it. So basically, you take a set of fractions, and I have a little example here. You can see that my example shows cross eyes, and the reason that it shows that is because we often use the term cross cancel when we're talking about canceling with fractions. So when we cross cancel fractions, we take this numerator and this denominator and we see if we can reduce them. We take this numerator and this denominator and we see if we can reduce them. So we're working crossways to see if we can simplify our fractions before we do anything with them. So what does that mean? Let's take a look. If I have 1/2 times 2/3, I can cross cancel by taking this numerator and this denominator. Well, in this case, there's not actually anything I can do with this numerator and this denominator because they don't have anything in common. But if you look at this numerator and this denominator, you can see that they're actually the same number. We can cancel them out. So we'll cross out the 2, cross out the 2, and we'll turn this into a 1 and this into a 1 because they cancel each other out. So instead of having 1/2 times 2/3, I made this simpler by getting rid of my 2's, calling them 1's, and saying 1 times 1 is 1, and 1 times 3 is 3. Now if we had worked this out, we would have 1 times 2 is 2, and 2 times 3 is 6. And then we would have to reduce that, and we know that 2/6 equals 1/3. But we made work easier for ourselves by actually simplifying before we did the math. Now I want to take a couple of larger numbers, maybe trickier fractions here to multiply, and use cancellation to show you how beneficial it is when we're multiplying fractions. So if I take a look over here, I have 5/9 times 7/10. So I care about this numerator and this denominator and this numerator and this denominator because I always want to cross cancel. Think of those cross eyes or think of making an X, whatever it takes to help you remember that you're going crossways. Well, if I take 5 and 10, it's almost like reducing. So if I think of a greatest common factor, my greatest common factor between 5 and 10 is actually 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. 9 and 7 are both prime numbers. That means remember that no other number besides 1 and themselves go into those numbers, so we can't actually do anything with them. But now we have an easier multiplication problem. So we have 1 times 7 is 7, and 9 times 2 is 18, and it cannot be reduced. But if I would have taken my original numbers, 5 times 7 equals 35, and 9 times 10 equals 90. This is a little bit harder to reduce because 90 is a bit of a big number. So you can see how it's beneficial to do the reducing or the simplifying first rather than later so that you have a smaller problem that you're working with in the end. Let's do the next one. I have 4 and 12 and 5 and 5. Well, I always like to start with the top left numerator. So 4 and 12. 4 can go into 12. Let's use that as our greatest common factor. So I'm going to divide 4 by 4, which is 1. I'm going to divide 12 by 4, which is 3. And 5 and 5 cancel each other out. So we can turn these both into 1's. 1 times 1 is 1, and 1 times 3 is 3. If I had done this without reducing these first, without cross-canceling, I would end up with 4 times 5 is 20, and 5 times 12 is 60. I would have to do some work to reduce this down. First, I'd get rid of those 10s and I'd have 2/6, and I know that 2/6 can reduce down to 1/3. But isn't it a lot easier to do it at the front end of the problem than the back end? I think so. I want to work a couple more problems for you for examples, and then I'm going to go ahead and give you your practice problems. Here's a case where we have some really big numbers that we're multiplying, and so it's pretty obvious that we'd want to cancel from the beginning. So if I take 25 and 50, I know that 25 goes into 50 2 times. So that's automatically my greatest common factor. 25 divided by 25 is 1, and 50 divided by 25 is 2. Now I have 9 and 27, and of course 9 goes into 27 evenly, so that's my greatest common factor. 9 divided by 9 is 1, and 27 divided by 9 is 3. So I have 1/3 times 1/2. Well, 1 times 1 is 1, and 3 times 2 is 6. I think that's a lot easier than having to multiply 25 times 9 and 27 times 50. I would have to write that all out separately like this, because I don't know that in my head. Then I would come up with my answers, my product, and then I'd end up having to reduce. And I'd probably, if I didn't find a greatest common factor right off the bat, I'd have to reduce a couple of times before I got to a simplified answer. So you can see where this is a lot easier than doing this kind of work. Last one I have here is 6/10 times 7/8. Well, let's start with the 6 and the 8. My greatest common factor for the 6 and the 8, I'd like you to think about it. Did you come up with 2? I hope so. 6 divided by 2 is 3, and 8 divided by 2 is 4. Now there's nothing I can do with my 7 and 10, so I'm going to leave those 2 alone. There's nothing I can do with them. 3 times 7 is 21, and 10 times 4 is, of course, 40. This looks like a big fraction, 21/40, but it cannot be reduced. There's nothing you can do to this fraction to make it any smaller. We know that 3 and 7 go into 21, but they don't go into 40, and so this is a reduced fraction already. So for your practice tonight, I have 2 problems for you. The first one is 3/10 times 4/3, and the second one is 7/8 times 4/21. And in both of these fraction multiplication problems, you're going to cancel both sets of numbers. So you're going to cancel this way, and you're going to cancel this way. You'll cancel this way, and you will cancel this way. You can see right off the bat that you have a 3 and a 3, so you'll be starting by canceling those down to 1, and that's the only hint I'm going to give you. You should end up with answers that are already simplified. If you have to reduce your answer anymore, you need to go back and start over with a greatest common factor when you're simplifying or canceling from your multiplication problem.